plus c. Okay. All right, like we were saying earlier, 8/3 plus c is some number. When we take the square root of some number, our answer to that always has to be positive. But in this case, our output is -3. So that tells us that we have to have a negative sign in front of the radical. So -3 equals negative square root of 8/3 plus c. Okay. In order to get 3, because we have this negative here, what do you have to take the square root of in order to get 3? 9. So now I'm going to set 8/3 plus c equal to 9 and solve for what c should be. Okay, so if I subtract 8/3 from both sides, I can think of 9, if I want to get a common denominator, then 9 is the same thing as 27 over 3 minus that 8/3. 27 minus 8 is 19 over 3. Did I do that right? Yes. So c, therefore, c is equal to 19 over 3. Okay. Now I'm going to plug all that into my general solution to get my particular. So y equals negative square root 2x cubed over 3 plus 2x squared plus 19 over 3. And there I have my particular solution. Okay. Okay. These next two questions are the same process, meaning you still have to find the general solution, then use your initial condition to solve for c, and then finally use your c value to write the particular solution. But these involve one additional step after you take the integral. Okay, so let's think about this. Find the particular solution to this differential equation. This is a separable equation, so if I separate the variables, I get dy divided by y minus 2 equals x to the 4th dx. Okay. So I have separated the variables. Now I'm going to integrate both sides. When I integrate dy over y minus 2, you can also think of this as the integral of 1 over y minus 2 dy. So take the antiderivative of 1 over y minus 2 with respect to y, if that is a little easier to see. Okay. This is one of those times where like reverse power rule does not work. But think to yourself, what do I have to take the derivative of in order to get 1 over y minus 2? After you give it some thought, you should be able to see that the integral of 1 over y minus 2 is equivalent to ln of the absolute value, don't forget about those, absolute value of y minus 2, plus some constant c. Okay, so ln of absolute value of y minus 2, that's our left-hand side. On the right-hand side, we can use reverse power rule, so x to the 5th over 5 plus c. Okay. So we have taken the integral, but this is when the extra step comes in. We have to isolate y to get our general solution. How do I get rid of an ln? Ln and exponentials cancel each other out. So if I exponentiate both sides, I'm going to raise each side, I'm going to raise e to the power of each side. So I'm going to say e raised to ln of the absolute value of y minus 2 equals e, I'm going to sneeze, e raised to the x to the 5th over 5 plus c. All of that's in the exponent. Okay. E raised to ln completely cancels it out. So on the left-hand side, I'm just left with absolute value of y minus 2. Okay. On the right-hand side, I want to split this up a little bit. I have e all raised to x to the 5th over 5 plus c. Use your exponent rules. I think it's easier to see that if we have like x to the 12th, for example, and I wanted to separate this is the same thing as x raised to the 7 plus 5, which is the exact same thing as x to the 7th times x to the 5th. When you multiply powers with the same base, you add the exponents. So e raised to the x to the 5th over 5 plus c, I can think of as e raised to the x to the 5th over 5 times e raised to the c. Okay. E is some number. Well, it's like 2.712. So I have e raised to a constant. E raised to a constant is just another constant. So just like last time, if I'm going to call e to the c my new constant c, then I have to go back and put a subscript on all of the c's I've used before. So c sub 1, c sub 1, c sub 1. So e raised to c sub 1, I'm now just going to call c. So if I rewrite it a little bit, I have absolute value of y minus 2 equals, we have c times e to the 5th over 5. So my right-hand side, I'm going to put the c in front now, because we're more used to the coefficient in front. So c times e raised to the x to the 5th over 5. Okay, I'm still solving for y. I'm still trying to isolate y. On the left-hand side, I need to drop the absolute value symbol. When I drop it, I'm going to add a plus or a minus sign to my right-hand side of the equation. So when I drop absolute value, I have y minus 2 equals plus or minus c e to the x to the 5th over 5. Okay. This is a little strange the first time you hear it, but plus or minus c is again just another constant. C right now could be a negative number or it could be a positive number. So think of this plus or minus as being absorbed into what I've called c. But just like up here, when I called e to the c sub 1 c, now I'm going to call plus or minus c my new c value, which means I have to go back and put subscripts on the other c's. So now plus or minus c sub 2, I'm now going to call just plain old c. So now I have y minus 2 equals c e to the x to the 5th over 5. My last step to isolate y is add 2 to both sides. Y equals 2 plus c e to the x to the 5th over 5. Okay. So it took a little bit longer, but now I have my general solution. Now I'm going to use my initial condition, 0, 0, to find out what c is. Okay, so y equals 0. I'm running out of a little bit of room, but so 0 equals 2 plus c e to the 0 raised to the 5th over 0, or I'm sorry, over 5. That is all 0. E raised to the 0